Yes, we did do this last year, just don't remember it. I'm going to explain that to you right now. Okay, so in terms of what we have to cover, we don't necessarily have to talk about inverse trigonometric functions, but it's very valuable because every year you guys ask questions about it on 7.5. So I want to just do a brief introduction on it. Okay, this is going to be an easy assignment for you. The first stuff will not be on your test. The second stuff will be. And then we're going to get into 7.5 where you have all sorts of questions starting tomorrow. Okay, we'll take baby steps through it. It'll all be fine. But just note, no, Lucas does not remember this because it's not very often you use this. But if somebody refers to it down the line, I want you at least to have a reference because next year in Calc, I might choose to use this a little bit more. So I want you to write something at the top, okay? I want you to write this. Say, cosecant of x is not the inverse of sine of x. That's something that students always get confused with. So cosecant is equal to 1 over... Cosecant is 1 over sine. They're multiplicative inverses, but they are not inverses in terms of operation. And what that means is, you know, you got to undo something. Okay? Do you remember this from college algebra? Do you remember when we covered this? Do you remember our inverse functions where the x and the y switch spots? That's what we're talking about. Take out your calculator and I'll give you a visual for what we're actually looking at, okay? So, go into y equals, and I want you to type in sine of x. Sine of x has an inverse. It's not cosecant. That's the reciprocal. So what you want is the inverse operation. Second, sine. That's sine inverse. And they refer to it as arc sine. It's totally cool what happens here. You guys are really going to like this, okay? Are you excited? Tara? 1 to 10. 1 to 10. What's your excitement level?
12.
Greta Johnson says, liar. Greta Johnson's a liar. Okay, we got it on tape. There you go. All right, so go in and let's change our window. Okay, we only want to view a certain portion of the graph. We're going to view sine of x, and we're going to view sine inverse of x. So you guys are going to see how those are related. Let's make our inverse function bold, so it stands out. Let's go in our window. Okay, let's talk about sine of x. All right, we're going to view it over the course of negative pi to positive pi. Whoop. And I'm just choosing that because that's just going to be a nice window for us. But you tell me this. What is the minimum y value that sine of x can obtain? -1. So let's do -2 so we make sure we see the whole thing. What's the maximum value that sine of x can obtain? +1. Let's go to 2 so we can actually see the whole thing. Okay? Are you ready? The first function will be sine of x. What's wrong? What's wrong? Somebody tell me what's wrong with the calculator. Yep, exactly. I'm in degrees. Okay, we'll try again. Just go to mode. You can go to radians. Does that look like sine of x? Yeah, that's sine of x, isn't it? The dark function is arc sine of x. And what it does is it takes all the x values and maps them to the y values. It takes all the y values and maps them to the x values. But we'll see if you guys can get this next question. What do you notice about this arc sine that's different compared to sine? What makes it unique? Why is this weird? It stops. Why do you just have a little segment? Yes. Yeah, very good, very good. Haley sees it. Watch. If you have And then we'll start drawing these out, and it'll all come to you, okay? So we're providing the base work. Here you go. This is sine of x. If we were to actually take this and map all the x values to the y values, it would start to look like this. Why can't we draw that? It's not a function. Your calculator says I can't draw something that's not a function, right? And so what it does is it only draws a very specific domain and range for that function. So this is all we have for the arc sine values. This is all the graph is. That's it. Let's understand why. Turn to your sheet. Let's look at our sine function. We're going to start back here at negative pi over 2. And we're going to go to positive pi over 2. Again, what's our maximum value for sine? Positive 1. What's our negative value? Negative 1. We're going to start down at negative 1. And we're going to curve up and top out at positive 1. So you tell me, of the sine function in this given region, what is my domain? State my domain. Of just what I've mapped here. What's my domain? Yep. Negative pi over 2 to positive pi over 2. What is my range? Negative 1 to positive 1. Are you ready? Here's where it happens, guys. When we find the inverse, it flips what values? The x goes to the y, and the y goes to the... So this stuff goes here, and this stuff goes here. So now what we're going to do is we're going to make our own sketch of arc sine. We've already seen it. Now we're going to understand why it did what it did. So our domain is now going to be from negative 1 to positive 1. So I'm going to mark those values on the x-axis, negative 1 to positive 1. And the range values are going to become negative pi over 2, positive pi over 2. Pi over 2 up here, negative pi over 2 down. So when it has a y value of negative 1, it has an x value of negative pi over 2. Those switch. So now when I have an x value of negative 1, I have a y value of negative pi over 2. When I have a x value of positive 1, I'm going to have a y value of positive pi over 2. Very good. And that's the function. Why can't we continue on with it? Why wouldn't it be a function? What does it not pass? The vertical line test. So therefore it ceases to be a function. Your calculator could not properly operate with it. Now, you guys, I want you to think about this. Look at what this does, okay? This is arc sine. Somebody give me a value between negative 1 and 1. Any value. I don't care. 0? Okay. Can you do sine inverse of 0? Can you type that in your calculator and get a response? Yep, it's 0. How about sine inverse of 0.2? How about sine inverse of 4.5? No. Remember when we were solving for triangles not too long ago? Side angle side stuff? And you guys would come up with, you're like trying to sine inverse like 1.3 would give you no results. We had no solutions to those. This is because the domain for arc sine is only between negative 1 and positive 1. And it will give you outputs between negative 90 degrees and positive 90 degrees. Or negative pi over 2, positive pi over 2. Let's try the cosine, okay? We're going to map cosine from positive 1 up here. They're already bored. Oh, gosh. Thank you. Okay, so now we got the cosine function, okay? Oh boy. I start up at positive 1, I go down to negative 1. I'm just showing this portion of it because I want to show between negative 1 and positive 1. That's why I'm showing just this portion. Okay? Remember, cosine starts at the top and ends at the bottom. Okay? So the domain in this situation is what? 0 to pi. Very good. What's the range? -1 to +1. Good. What happens when we switch? They flip. We go domain is now -1 to +1, and we go range is 0 to pi. So let's get an idea what this graph is. What do you know? Look at the range. This is kind of unique. 0 to pi. What do you notice about those answers, 0 to pi? Those are all positive. Yeah. When you cosine inverse, you only get positive results. When you sine inverse, you can get negative results. And you can check all that stuff on your calculator. And this is the reason why. So the reason why we're covering this is because tomorrow when we solve for trig functions, you guys will be saying to yourself, Mr. Gantz, why when I press this into my calculator do I get, whoops, she's not here. She had to leave. She had to go to like some, I don't know, club. I don't know. Andy. Just Andy. Okay, so you guys are going to be asking, why do I come up with these values? And, you know, this is why, due to the type of ranges that they have. So I have ranges 0 to pi. I have domain -1 to 1. It looks like I have this first point here, which is 0, 1. So now I'm going to have a point over here of 1, 0. It looks like I have a coordinate right here of 0, pi over 2, 0. So I'm going to have a coordinate over here of 0, pi over 2. And here I have a coordinate of pi, -1. So over here I'm going to have a coordinate of -1. Positive pi. So that's arc cosine. That's what it looks like. And if I grab my calculator and I look at my function again and I finally get it to turn on, if I type this in, and you'll verify this, a second cosine inverse, graph it. Look what I get. That's cosine. That's arc cosine. I can't quite finish it off. If I move up the window just a little bit here, if I go to y max of like 4, now watch what happens. You're going to see the top of it. So that's cosine. There it goes. See, pretty much like what we have, right? And that's it. So they have function values, and that's why your calculator is able to obtain those. Okay, you guys need to understand something. They got them. All right. So we move on. Let's get to the rest. We're not going to do them all. If you want to, you can view the rest of these on page. Well, just look at 7.4, and you can see the rest of them if you want. I'll do one. I'll just do tangent. If you recall, tangent looks like this. I'll draw it in blue. And it has vertical asymptotes. Well, if we were to take the inverse of that, it's going to have horizontal asymptotes through pi over 2 and negative pi over 2. And then it just changes. It goes from here to that. And that's it. And you can do the others. We're not going to do them, but you could do the others. And then you could calculate the domain and range and everything else. Okay? All right. You need your unit circle, your graphic organizer. Now we're getting the stuff that you're actually going to have to do on the test. You also need your calculator. Okay, look on your graphic organizer. What is sine inverse of 1/2? What do you get? Where is sine equal to 1/2 on your graphic organizer? 30 or 150. Okay, so pi over 6 or 5 pi over 6. Now the question is, why when you type that in your calculator, now try on your calculator, work in degrees. So we're going to go to mode. And I'm going to degrees. Here I am. And I'm going to go sine inverse of 0.5. And I only get 30. Well, what about the 150? Why don't I get that? Because it's restricted to a certain domain and range. Look, your range is only going to be between negative 90 degrees and positive 90 degrees. Well, which one's between negative 90 and positive 90? Only 30. That's why you only get the one. If you wanted to get the other, you'd be forcing arc cosine or arc sine to not be a function anymore. So that's why you don't get that, okay? So there are two values, but this is the one primarily that we come up with on our calculator. How about tangent of negative 1? Where is tangent equal to negative 1? 135 degrees, 315 degrees. Now here's the problem, you guys. The domain for tangent inverse is only between negative pi over 2 and pi over 2. That's the domain. Neither one of these is between there. Hit it on your calculator. Go tangent inverse of negative 1. What do you get? Negative 45. That's because it falls in line with that. Well, which one of these is the same as negative 45? Yeah. So what I'm saying is that your calculator gives very specific values that we don't always use or come up with. So technically, tangent inverse of negative 1 is negative pi over 4, or negative 45 degrees. Technically, that's the answer. Now, often we're going to use 135 and 315, but I want you to understand what your calculator is doing. How about cosine inverse of 3? Don't even do it on your calculator. Just tell me what it is. You can do this. What's the cosine inverse of 3? Why? What's the maximum value that cosine can achieve? 1. It can't achieve 3. So you can't cosine inverse 3 or negative 3, just between 1 and negative 1. All right, where is cosine equal to the negative square root of 3 over 2? Look at your sheet. Where's it equal to the negative square root of 3 over 2? 150 degrees or 210 degrees. But if you look at the range, it only outputs between 0 and pi. So which one is it, or 0 and 180 degrees. So which one is it going to give you on your calculator? Try it on your calculator. We'll do cosine inverse of square root of 3 divided by 2. And I got to do a negative in there. And if I do that, I have an extra parenthesis and need to change it. Okay, and I get 150. So you can see that's what your calculator is doing. It's coming up with those values that we've described. Got it? Okay, now, these are the examples that you have to know for your test. The first one won't make sense. The next three will. Just bear with me. Trust me. Trust me. Trust me. Trust me. I have a triangle. I'm going to put theta right here. Is everybody okay so far? The problem states, evaluate the expression by sketching a triangle. I would like to know the sign of cosine inverse of 1 over 2. So, first of all, what is cosine? Cosine is, in terms of opposite, adjacent, and hypotenuse, what is cosine? Opposite over hypotenuse. This is on your sheet. As I look at Anderson's organizer, it's right here. And as I flip it on the other side, it's right here. These are all right here for you. You can refer to them if you need to. So, what that means is the opposite side is going to be 1. The hypotenuse is going to be, no, it's not opposite over hypotenuse. What is it? Adjacent over hypotenuse. Sheets around, yeah. Okay. The hypotenuse is 2 and the adjacent is 1. How can I find out the opposite side? Yep, Pythagorean theorem says it's square root of 3 over 2. Right? No, just square root of 3. There we go. So, that's my triangle. Now, here's what you got to think through. If we do cosine inverse or sine inverse or tangent inverse, what are we coming up with? What are we solving for? If I'm doing sine inverse of something, what am I getting? Yeah, I'm getting an angle, right? Like sine inverse of 1/2. We've already said that that's equal to like 30 degrees. You don't have to know what the angle is. When we cosine inverse, we come up with an angle. So we know what cosine inverse of 1/2 is. It's that angle. So now the problem changes. Instead of trying to find sine of the cosine inverse, I'm just trying to find sine of the angle. Because cosine inverse gives me an angle. What's sine of that angle? Sine is opposite over hypotenuse. Opposite over hypotenuse is square root of 3 over 2. So this answer right here is the square root of 3 over 2. Bada bing, bada bam, bada boost. You'll see it easier the second time. Sine inverse, 4 over 5. In terms of this opposite adjacent hypotenuse, what is sine? Opposite over hypotenuse. Very good. So, I draw my triangle. I've got theta. 90 degrees. Opposite is 4. Hypotenuse is 5. What's the adjacent side? Yep, 3, 4, 5 triangle. Or you can do a squared plus b squared is c squared, Pythagorean theorem. If you sine inverse something, what do you come up with? We come up with theta. So this problem changes to cotangent of whatever theta is. What is cotangent in terms of sine, or opposite adjacent hypotenuse? Adjacent over opposite, which is 3 over 4. And this is all you're going to be expected to do on your homework. This is it. Yeah, go ahead. Yeah, you do the next one on your own. Go ahead. Hey, yeah, how about that? Somebody come up and do it for the class on YouTube. Yeah, come on, grab the microphone. Oh, Cody stepped up and then he shrunk back. Maybe Lucas wants to educate the class. Does Tara already have it? Well, she hasn't even started the problem yet. You got to draw a triangle first, and then you got to put theta right there. Who's got it? Who's got it? Pythagorean theorem. You're smart. Every day, get up and look in front of the mirror and say, I'm good enough, I'm smart enough, and doggone it, people like me. Stuart Smalling. Daily affirmation, Saturday Night Live. Anna, you got it right. Come on, come on, come on. Grab the microphone. Clap if you'd like to see Anna do the problem. Oh, yeah. Come on, Anderson. All right, I will narrate. All right, she picks up the pen. Just trying to identify the appropriate sides. Secant is hypotenuse divided by adjacent. I don't know why she wrote it where she did, but it's correct. She's kind of lost. Uh-oh, she's getting it back. Now she's executing the Pythagorean theorem. She must be solving for an unknown side. We don't know what that side is yet because she hasn't labeled it. When will she label her sides? Oh my goodness. 1 and 3, she's correct. Adjacent and hypotenuse. Can she figure out in simplest radical form what x's? She's going in. She has x squared is equal to 8. Oh, I'm ahead of it. 2 square root's of 2. She's correct. She goes in. She writes 2 square root's of 2. Now she needs to evaluate tangent of theta. Tangent is opposite over adjacent. Square root of 2 over 2 over 1, which is the square root of 2, or I'm sorry, 2 square roots of 2. Oh, very good. Nice job. All right. Crowd goes nuts. And they clap. Okay, let's do the last one. Nice job, Anna. Everybody see it? Okay, very good. We do the last one together. I draw my triangle. I put theta right in the corner. Guys, these are easy points on the test. Please do me a favor and yourselves. Don't get these wrong. I don't want to grade these on the test. I just want to go right by them. It saves me time. Okay, so just get them right. These are supposed to be the easy points. Cotangent is, in terms of opposite, adjacent, hypotenuse, what? Adjacent over hypotenuse. Thank you very much, Tara Westland. Adjacent over opposite. So opposite is 5. Adjacent is 12. What is the hypotenuse? 13, because it's a right triangle and it's a special one. Very good, Mallory Gill. It's a Pythagorean triple. The Pythagoreans back in Greece were fascinated by Pythagorean triples. You guys know, like 3, 4, 5. Oh my gosh, there's 5, 12, 13. There's 7, 15, and 17. No, 8, 15, 17. There's 7, 24, and 25. There's any replica. We can even derive a formula to predict them. Okay. So now what we need to do is we need to find the cosecant of theta. Right? If I cotangent inverse, I come up with theta. What's the cosecant of theta? Got it? You got it. Here is your assignment. 7.4, page 567, numbers 29 through 38. 37, 38 have a special little trick. I'm not going to tell you what it is, but there you go.